Hello everyone and welcome to the TechHit channel, and today we are going to deal with data types, switch statements and for loop. So in the previous lecture we studied about the input and outputs, the if-else statements and a little bit of data types. But what was left is discussing about the size and range. So now let's first of all understand what is the importance of this thing. Like, why am I discussing about the size and the range of the data types? So for that, I'll let you know one thing. In the previous lecture, I discussed about int a, which is called the declaration of variable, right? And I told you that this is done in order to allocate memory, because in order to store a variable, you need to have a memory reserved for it, right? So for that purpose, we declare the variable first and then we take the input. Okay. Now, what is the role of this int? Why a data type is also used in declaration? So each data type has been assigned a particular bytes in the memory. So when we declare that int or double or float or whatever, we tell that this much byte is assigned to this variable. We ask the CPU that assign this much byte to the variable, because and once we say this, like once we type this, it understands that okay, when I'm saying that I'm using int, that means my values of a would be falling in this range. Now why and how this range is decided? So this is done on the basis of what I'm going to explain right now. So see, I said there are 4 bytes assigned for int, right? Now I guess everyone must be knowing, but for those who don't remember, 1 byte is equals to 8 bits, the very first thing that we studied in computer. So 1 byte is equals to 8 bits, right? So these 4 bytes means there are how many bits? 32 bits. Okay, and then and one more thing, that our computer understands only binary language. So whatever input you give, suppose you give 5, so it will first convert it into binary and then it will store in the memory, right? So, and binary, you know, is just made up of 2 things, 0 and 1 combinations, right? So this 0 takes 1 bit to be stored and this 1 takes 1 bit to be stored. Okay, so that means we can store about 32 zeros and 1 combinations in int, right, for making a number. So let me tell you how it is done. So this 32 bit is not entirely for the value that you input. No, it is also for, I'll tell you one very interesting thing. So this is 31 and this is 0. So the first bit, the 0th index, is reserved. Now for what purpose is it reserved? It is reserved for deciding whether it is an unsigned variable or is it a signed variable. Okay, so and now left of the memories, that is the 31 bits, are used for this value. Whatever value is being stored in this A, that value will be stored using the 31 bits. Okay, so we have 2 options, either 0 and 1, 0 or 1. So now how we will be deciding the range of this int variable? For that, it is minus 2 raised to the power of 31 to 2 raised to the power of 31. Is it this much only? No, it is 2 raised to the power of 31 minus 1. Why? Because in the positive side, 0 will also be included, right? So hence it's 1 minus. Okay, so this is the range. So in this range, if whatever value you are inputting in this variable a, if it falls in this range, there won't be any problem in printing that, right? But as soon as it crosses this limit, there would be a garbage value or an error given to you. Is it clear to you? Okay, so this is the concept which goes the same for all the data types. So I just had to explain this particular thing. Let's move on to the next thing that I had to let you know, and that is what? That is the switch statements. Now let's come to the VS Code and see the switch statements. I hope the screen is clearly visible to you, and yes, now let's go. So for switch statement, I say we have already studied if-else, right? So it works in a similar way but a bit different. Now how it is different is, in the if-else statements you can make comparisons, but in switch case you cannot make comparisons. You just have to print it. This is the question. So how will you code this question? So for that, you can use definitely if-else, but how switch works, let's first understand that. So first of all, you will take an input char ch that we have already discussed. Before taking input, we declare a variable. So we will take an input now, and here the switch thing works in the manner that it will take ch as its parameter. Okay, then there would be the braces, and then comes case. Now how is this case decided? So it can either be one or like any character can be there, or an int can be there. Suppose if we have to print that okay, 1 is equals to Monday, 0 is equals to Sunday, and then like that way, then we have to also use the case statements. Okay, so suppose it's case A, that means we input what? We input A in the ch, then what we want to be printed. So I want cout vowel, right? And then let's come to case, next case. So it says E, then again we have to print vowels. Then next case I, then again we have to print its vowel, right? So in that format we have to print it for all, A, E, I, O, U, all of them needs to be printed. Okay, so I've printed this, right? Now suppose, okay, and now what to do with okay, so we have printed for the vowels. Now for the vowels, we know that if it's A, it's E, I, O, U, we have to print vowel. But now what to print if it's consonant, and how to print that? So for that rescue comes one more statement, that is default. Now in the default case, you will write cout and consonants. That means when all of these statements won't be satisfied, it will run whatever is written in the default. Okay, now see, suppose I input, okay, I'll run this program. Okay, suppose I input O. What should it print? It should print vowel, but it printed vowel, and consonants also. Now here comes the concept of fall through that I want to tell you. Now what is fall through is, if suppose I input A, then all the rest of the cases would also be executed. But I don't want it. I just want that it prints vowel for A and then it leaves. It doesn't print the other vowel and then consonant. I don't want that. I just want that it should print whether A is a vowel or not and just end with the execution. So for that we use the break statement, and these are called the control statements. Okay, so break, like we will be adding break in all of the cases. So that why we add? In order to avoid the fall through. Fall through meaning executing all of the rest of the cases even though it satisfies just one case. Okay, so let's see. Now after like this last case, you don't need to put default, don't need to put break in default as well. Okay, you can just go with this. We'll execute, and now we will see the output difference. So now if I input O, it should print just vowel, right? Let's see, it just printed vowel, nothing else, right? Now don't you think it's very odd to see writing so much for just vowel things? Can we do some modifications to this code? Yes, we can. We can include all these things in just one case. How we can do is, we can use this thing and we can put it here. So we are giving it a choice. In short, we are giving it a choice that if you get either of these cases, print vowel. Okay, this is how it works. Let me show you. So what will happen is, whatever the case, whenever one of these cases would be fulfilled, it will print vowel. Okay, and it will then break. And if none of these cases are fulfilled, then it will come to default and print consonant and over. Okay, so that is for break and the use of case statements. So let's just execute it and see. So suppose I want to say if B is a consonant or vowel. It's a consonant. It directly came to default and it executed this particular line, right? Now suppose I want, let's check if it is going good for the vowels or not. So if I input U, what should it print? It should print vowel. It printed vowel, right? So this is the better optimization of the code. Or suppose, let's take another example. Another example can be, suppose I want to print 0 for Sunday, then I want 1. When it's 1, I should be printing this, and so on, right? So for that case, now what we will be doing is, first of all, let's comment this, and what we will be doing is case 0. Okay, now moreover, this thing won't be character anymore. Now it will change to integer. Okay, so case 0, I like to print Cout, Sunday, Endel, and break is very important. Remember that, because other than break, if you don't put break, fall through will take place, and that we don't want it. So here is the entire program written. Now let's come to default section. If it's default, what we want to be printed. So when it's default, we can say it's invalid input. Okay, that's it. We are done with the program. So this is the entire program for printing the day number and the day, right? Let me execute now. Okay, suppose I enter 4. It should print what? Thursday. It has printed Thursday. Okay, so this is what is switch case. So let's dive it into the array and strings part on the board. So arrays and strings. Suppose we have to take many integer type values. How we will be storing it? Will it be like int a is equals to 5, then int b is equals to 6, int c is equals to 1? Will that be fine? Is it okay to use this way and then keep on printing Cout A, then enter, then Cout B, then enter, then Cout C, and then enter, then Cout D, and then enter? Is that the correct way to take input, to initialize and then print it? No, it's not. It's taking so much of lines and printing statements. Suppose here are only 4, but what if we have hundreds and thousands of variables to be declared? Hundreds and thousands of integer type values to be stored. So for in that case, we use arrays. Now what is the concept of array? It works like, just a second. So int ar this, and suppose I want to just keep it like this, and I want to declare a size of 5. So array size of 5, meaning I can store 5 integer type values in this particular array. Okay, so now how will we visit different values? So here comes the concept of indexing. So let me just first explain it theoretically so that you are clear with the concepts, and then we will move over to the code. So what happens in array AR5, right? This is what we took as the example. So AR5 means int data type, right? So 5 numbers we have to store of integer data type, right? So there would be an array of 5, that is 0, 1, 2, 3, and 4. This is the array of 5, right? And it is of integer data type. Is it clear? So each one of these would be of 4 bytes. No issues in that. I told you already that whenever it's integer, that means it will have 4 bytes. But since there are 5 integers to be stored, so what would be the size of this AR variable? It will be 4 into 5, that is equivalent to 20 bytes. Is that clear? So int AR5 is equals to this. So this AR variable in the memory, how it will work? It will create a continuous, first of all, array is a continuous memory storage. Okay, so all these number would be stored in a continuous manner. Okay, suppose in memory this AR gets the memory location of 2000. Okay, so the first index, that is the 0th index, will have 0200 as the memory location. For the first index, it will be 200. What would be the next? It would be 4, not 2001. Why not 1? Because 4 bytes have been given to the first index. Why first index? Because it is storing an integer value. All these individually are integers only. They are not connected. They are just connected with the thing, that is they are belonging to one data type, that is int. Okay, so each one of these would be having 4 bytes, right? So 2000, 2004, then 2008, then 2012, and then 2016. So each of these indexes would be provided, would be reserved in the memory, okay, for AR variable. And these are stored in continuous memory location, okay. So wherever, like, AR can be reserved anywhere. Might be it's at 3000, might be it's at 1301, 3014, or whatever, but it would be stored in the continuous manner. And what I mean by continuous manner is explained here, right? Okay, so let's come here now. So I want to store, first of all, we have declared there is an array of data type int, and number of variables that are there are 5, right? Let's take an input in this. Now for taking input in the integer variable, okay, let's for telling the input part, I'll have to tell you the for loop concept. So at that time only I'll let you know. Before that, suppose I want to put AR0 here, indexing box. Okay, now what is indexing? Indexing is whenever number is stored at this particular place. Okay, whenever number is stored at this particular place, so it will be assigned with this index. So in order to visit this number, suppose I have stored 12, 4, 18, 20 and 23 in this array. Okay, suppose I want to visit this 20. How will I visit? So for visiting 20, I will say AR of 3. So whatever is the number's position minus 1 is the index, and you visit that particular value using the index. Okay, so what is the use of index? It is in order to visit that particular value in the array. Is that clear to you? So let's come here. AR0 is equals to, suppose I want to initialize it to 12, right, as we discussed. And now if we print cout of AR0, and then what will be printed? 12 would be printed. See, you can see it very clearly. 12 is printed, right? Now suppose I want to see what is there at AR of 3, but I haven't initialized anything to AR of 3. So what would be stored there? There would be a garbage value that would be stored at index 3 of the array. Okay, so whenever you declare the array, there is garbage value stored in each of its indexes. Okay, so whenever you have not initialized any index, that particular garbage value would be thrown as the output whenever you visit that index. Okay, so I haven't initialized AR of 3, so it has stored garbage value. Now when I want to visit this index, what will it throw me as the output? It will throw the garbage value. Okay, so let's see on execution what it gives me as the output. See, it gave some garbage value, right? Whenever I execute it next, it will give some other value. You can see that, right? So this is how the array works. Okay, now let's come to the part of string. And now I told you that it stores in continuous memory location, right? So you have understood about that concept also. Now let's come to the string concept. Now what is a string, and let's see. So for the string as well, indexing works. So suppose I have stored string s is equals to hello, right? And now I want to print what is there on what is the index of. So first of all, let me tell you, this hello would be stored in the indexing format only, because there are characters which are combined in order to form the string. So these characters are indexed. Okay, so whenever I want to visit a particular character, I will have to use indexing. Suppose I want to see what is at let me tell you how it is done. First of all, it's written hello, right? So HELL and O. So 0, 1, 2, 3, 4, and this is S, right? So if I write S of 2, what will it print? Let's see. S of 2 and then ended. So it will print what? It will print L, right? Let's execute and see. See, it printed L. Why it printed L? Because it is stored. See, your string is made up of characters, right? And the characters here are in text. So whenever you have to visit any particular character, you have to treat it in the same manner as you do for the array, right? So string is basically the array of characters. Okay, so now let's see the next thing, that is the for loops and while and do while loops. So different looping statements. Now what is the use of the looping statements? Why looping statements? So basically, suppose I want to print. So suppose I want to print, just a second. s is equals to hello. This is the string, right? And I want to print this hello 5 times. So what will I be doing? Will I go and write hello, 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 hello 5 times? See out 5 times. So see, suppose I have to write hello, then I have to write it like this. Right? This we will have to do in order to, for 5 time printing of hello, we will individually have to go and print it, right? So for, okay, it's 5. It's 10 also, then also we can print it. But what if it's 1,000 of things that needs to be printed? If it's 50, how are you going to write the 50 line of codes for the same thing? No. So in order to reduce that particular thing, that means what we are doing, first of all, we are doing the iteration. Iteration means we are repeating. We are doing the same thing again and again and again. So whenever we have to do the same thing again, we use the loops. So what we like, how does the looping works? Let's see first of all. So for loop, okay. So for loop has a particular syntax. Now what's the syntax? Let me first tell you. For int, I is equals to 0, I is less than, okay, let's not take 0, let's take 1, int 1, I is less than, suppose we have to, what we take the example, we have to print 5 times hello, right? So I is less than equals to 5, since we have taken 1 as the initialized value. So then I plus plus, right? I'll tell you everything in deep. First of all, let's see what it does. So see out hello. Okay, now just 3 lines of code and those 5 hellos would be printed, right? Let's see. Yes, it works. So here is the proof of the working. So now let's see how, like, what are the things that are used here. First of all, let's know the syntax. Basically what I want to tell is syntax portion. So for loop has a syntax of, just a second. So the for loop has a syntax of for, and then there would be an initialization, and you all know about how to initialize, okay? So there would be an initialization, then there would be a condition check, then there would be update of the statement, that is upgradation, okay? So these are the 3 steps in which your for loop works, okay? So yeah, there is an initialization, there is a condition, and there is upgradation, okay? So for the initialization, I have taken I is equals to 1, and for the condition I'm checking till I is less than equals to 5, we have to print this. So first of all, the control of the the control goes here, it initializes, then it checks for the condition, okay? Then once the condition is fulfilled, it comes inside the for loop, runs these statements, and then it goes to the upgradation part, and after upgradation again the condition is checked. Is that clear? So this is the workflow of the for loop. Now let's talk about the other loops also. There are 3 loops, that is for, while, and do while loop, okay? So for this class I'll just take these 2 loops. In the next class we would be discussing about the do while. So let's come to the while loop. So while loop has a different syntax. What is the different? Things are the same, just a bit of difference is there. That is, initialization is outside, okay? Initialization is outside, while, sorry, just a second, while, and here is the condition check, okay? Then inside, whatever statements are there are executed, and after these conditions are executed, there is upgradation, okay? So the upgradation happens at the last of this, inside the loop only, okay? And then again it checks for the condition, and then the loop runs. That's the thing, okay? So one thing I would like to tell you is for and while loop are known as entry control loop. Entry control loop. Now what are entry control loop? Entry control loops are the loops which check the condition while we are entering the loop, okay? So you can see that condition is being checked before we execute these set of codes. The condition is being checked, that is, there is first conditional check, then entry into the loop. Similarity is happening for while as well, right? And do while loop is known as the exit control loop. Okay, let's discuss the do while loop here only. Let's not take it to the next class. So let's discuss about do while as well. So in the do while loop, how things work is a bit different. Okay, so whenever you have to work in a manner that you want whether your statement is whether your condition is fulfilled or not, but you want that one time your code runs, like for minimum of one time it should run, it must run, then we use the do while loop, and this is known as the exit control loop. Now why exit control loop, you will come to know as I discuss it further. So it is called the exit control loop because first of all here will be the initialization, same as the while loop, no problem. Then there would be do, then there would be set of code that would be running, so a line of code that would be running. Then there would be an upgradation, okay, and after that there would be a while here, and there would be a condition. Okay, so this is the syntax of do while loop. So what it is doing, first it is initializing, then it is checking for nothing, and then it is executing the code. Like immediately it's executing the code, it's not checking for any condition. So in that case, whether your condition is fulfilled or not, your statement would be running for at least of one time, right? So whenever you have to print something, whenever you have to do a task that requires to be run for one time minimum, then in that case you use the do while loop. Okay, because once it runs the execution part, then it comes to upgradation, and after upgradation is done, then it comes to the check of the condition. Okay, so or even if this is not fulfilled, no problem, it has still run for the one time. Okay, so since the condition is the last step of checking, therefore it is known as the exit control loop, because we are checking the condition at the end of the looping looping structure. Okay, so that is the significance of exit control and the entry control loop. So let's first of all take the example. So we took this and we printed it, right? Now let's see the same way, like we have to take the same example and we have to do it in while, how we will be doing it. Let's see. Okay, so for the while loop, how will it work? I told you first of all it's initialization. So okay, I'll take int I is equals to 1. I have initialized. Then what I said, with the while we will be checking the condition. So for the condition I is less than equal to 5, right? And then after checking the condition, we will be doing the whatever part of the code needs to be executed, that the work that we have to do, we will be doing that, right? And once that thing is completed, we come to the upgradation part. So upgradation is I++. It was the same here also, right? So it will be here the same way. Let's check, does this gives the correct, the same answer? Let's check. Yes, it printed the same. There are 5 hellos here and there are 5 hellos here as well, right? Now let's see how do while will work. Okay, let's see that. So as I told you that for do while you don't need to check the condition before. Okay, so let's first of all see the do while thing. Initialization would be the first thing, right? Then do, and then we would be writing the code, right? So see out, I want to print hello, right? Sorry, I want to print hello. Okay, I have printed it, and then I will upgrade I++, right? And then after all this thing is done, I will check for the condition. So while I is greater than equals to, now for here what we will be putting is, let's first check, let me tell you one thing. I is greater than equal to 5 and semicolon. So we have taken the same initialization, the same condition and the same upgradation, right? Let's see something in the output part. Executed now. Okay, so 1, 2, 3 and 4 and 5. There are 5 hellos printed. Is that clear? So this is how your do while loop works. Okay, now suppose I put it something like I is less than 1. Okay, but I have taken it as I is equals to 1, I have taken it as I++, but at the checking of condition, I have put it I is less than 1. Let's see how the output will work. See, though the condition is wrong, yet it is printing 1 hello. Why? Because it is an exit control loop. Because first it doesn't checks for any condition. It first prints, like it first runs the code, and then after that it checks for the condition. Therefore, whether the condition is fulfilled or not, your statement, your line of codes would be at least executed for once. Okay. So that's it for this session, guys. So this is what I wanted to tell you for today. So we today followed up with switch case statements. We took arrays and strings and studied about the loops. So in the next session, we would be discussing on functions, how the functions are called, and then we would be discussing on some time complexity portion and STL. So let's meet in the next session. Till then, happy coding.